I'm going to talk to you about this eclipse. And assuming since you're here, you already know that there's an eclipse coming. It is now 4 weeks away. 4 weeks from today is when it's going to happen. And what I'm going to do is I'm going to talk about why we get eclipses, why it's such a big deal, and a little bit about what you can expect on the day, okay? But I'm going to start with real basics, because I think everybody knows that, you know, we've got the sun and the moon gets in the way of the sun, and we get an eclipse. But I want to step back just a step further than that, and that is talking about phases of the moon, because that is really what we get from how the moon moves around the Earth and the Earth moves around the sun. And so we need to understand moon phases before we can go anywhere else. So that's where we're going to start. And I'm going to start with a calendar of the moon phases for the whole year. So this tells us the moon phase for the whole year. We all know that we see a full moon every month, a new moon every month when we can't see the moon at all, and all the shapes in between. So I want to talk about why that happens. Now, one of the things that is really important is to think about how everything's moving. But let's start with just the moon is at this position. The sun is somewhere way off over there. The sunlight's coming in. The moon is here. It's lit up, but the side that's lit up is pointing away from us. That is new moon when we can't see it. And in fact, yesterday was the last new moon before the eclipse. So that's where the sun would be. The moon would be. As it goes around the Earth, it's going to move to this position. Then from this position, we're stood on Earth, we're looking at it, and we can only see this little bit, so we get a crescent moon. But the moon's going to keep moving, so now from looking on Earth, we're going to see half of it lit up, and we get the first quarter or half phase. It's going to keep moving around, and when it gets to this side, that lit up side is pointing towards the Earth, so we get full moon. But the moon's going to keep moving, and so now it's moving back around and getting smaller and smaller till we get back to new moon. It takes 29.5 days to go from new moon through all the phases and back to new moon. But when we look at an image like this, and this is the usual way that people present how we get moon phases, it begs the question, if sunlight's coming in and the moon's there, why don't we get a shadow every time it comes around? And so I want to kind of model this first, just having you all pretend that you are the sun. You're the sun, and my face is the Earth. And to have an eclipse, the moon, my fist, has to get between you, the sun, and me, the Earth, right? But most of the time, when we have new moon, the moon isn't here. It's either down here, where it's still in the direction towards the sun, but it's not blocking my view of the sun, or it's up here, okay? Now, if it's down in this position, it still has to go around the Earth, which is my head, and so when it goes around like this. And so what that means is that now you can see the full moon, because you can see my fist, the sunlight bounces off the moon and hits the Earth. So when we think about this, it's flat, but actually we have to think in 3 dimensions. So to kind of put that together in an image, the gridded portion is a plane, so it's like a piece of paper, and then where the Earth and the sun are on that same piece of paper, so I've got the Earth and the sun, and now the moon is going to go around so that when it's new moon, it might be up here. And when it's full moon, it'll be down there. And we're only going to get an eclipse when it's actually in between, okay? And that doesn't happen all the time. And so the way you can see it is that most of the time, and in this case the moon would be up here, now we've got the sun somewhere over there, the sun's coming in, the moon is here, and its shadow doesn't hit the Earth. This also explains why we see the full moon, so the sunlight hits the full moon and bounces back, and this side of the Earth sees the full moon. When we get an eclipse, it's because it's properly lined up, so the moon is right in the way. It also explains why you are more likely to have seen a lunar eclipse than a solar eclipse. How many of you have seen a lunar eclipse? Right. How many of you have seen a total solar eclipse? A couple. Okay, so here you can see we've got the moon, it's in the shadow of the Earth, it's eclipsed, but the whole of this side of the Earth can see that. Everybody who's in nighttime gets to see that eclipse. But on this side, the moon is blocking out the sun, but the place it's blocking out is only that little bit there. And so we actually get solar eclipses and lunar eclipses with the same frequency. They happen the same amount of times, but we're more likely to see this one. So let's put the whole thing together to figure out how often we actually get eclipses. So what I've got here is, again, the gridded thing is just a plane like a piece of paper. The sun is in the middle. It's in the middle. The Earth is going around. And if we look at this point, if I was to draw a line from the Earth, which is going around the sun, to the sun, now the moon here would be underneath. So it's back to this position where you guys are the sun and my face is the Earth. The moon is down here. So the moon is here, but it stays at that angle. So as the Earth goes around, now when it gets to here, it's going to be down at that low point, but it's over here. That's a half full moon. And as it comes around, it's going to get in between. So here we get an eclipse. But the Earth is going to keep moving. And as it keeps moving around, it's going to be out of alignment again. We don't get an eclipse, really don't get an eclipse. But when we get back around to this side, we get an eclipse again. So we actually get a lining up of the sun, moon, Earth twice a year. Not every time we get a lining up are we going to get a total solar eclipse, and I'll come back to that later. But also, even though we get almost half of them will give you a total solar eclipse, we get a total solar eclipse somewhere on the planet almost every year. But it only is seen from a very small portion of the planet, and so you have to be in the right place. So now what I'm showing is, here I've got the sun, and here's the moon, and here's the Earth. And if you want to be standing on the bit of Earth where you cannot see the sun at all, you have to be on that little tiny dark spot right there. Okay? That little tiny dark spot is about 70 miles across. And so anywhere else on the Earth, so if I look at, that's where I'm from, if I was standing there, I would be able to see the sun just as normal. If I'm in this slightly darker phase here, so if I'm stood right here, the moon's going to block out this side of the sun, but I can see this side. That's a partial eclipse. That's where the moon is only blocking out part of the sun. But only on that tiny spot is it blocking out the whole of the sun. Now, that's not the only place that you'll get to see it from, because everything is moving. Everything is always moving in space. Makes things difficult. So here we have, this is the way the Earth moves, and the Earth and the moon move around the sun. And the Earth is moving at about 20 miles every second. So they're both moving this way. At the same time, the moon is on its orbit, and it's moving this way, and the Earth is spinning. And so when you put all of those things together, it means that at one moment, this is where you need to stand. But the next moment, it's going to be here, and then here, and then here. So it kind of draws out a path across the ground where you can see the eclipse from. So for every eclipse that we get, it's going to be an area on the surface of the Earth that is about 70 miles wide and a few thousand miles long. Now that sounds like a really big area, but it's only 1,000th of the surface area of the Earth. So although they happen every year, the chances of it being your bit of the Earth are pretty slim. So on a planetary scale, eclipses are very common. On a local scale, they're really not. Now, before we go much further, I want to show you what's going to happen in 4 weeks. Okay, so this is the scale, and here's the moon, and here's the Earth, and you're going to see that tiny dark spot, that 70-mile across spot, and it's going to come into view right here. So that's the first place that's going to get to see this eclipse is happening in 4 weeks. It's over the Pacific, and it's going to hit the coast of the US, and the first place that's going to get to see it is Oregon. So it goes across Oregon, and then into Idaho, and across Wyoming, then into Nebraska, across Nebraska, and a tiny bit of Kansas, and then into Missouri, across Missouri, and then Illinois, and Kentucky, and Tennessee, and Georgia, and North Carolina, and out through South Carolina, and into the Atlantic Ocean. That's what's going to happen. And if you're not under that little dark spot, you don't get to see a total eclipse. Okay? Now, how long it's going to take to actually cross the country is 94 minutes. So it's moving so fast, it's almost 2,000 miles an hour. The fastest jet airplane cannot keep up with this thing. It's moving really fast. So you don't get long in darkness, but it's going to be cool. So the next thing I want to talk about is, well, what are you actually going to get to see during darkness? So this is kind of showing you, this is from a previous eclipse, and it's basically a time lapse. So each of these is a little bit of time apart. They're about 10 to 15 minutes apart, 10 minutes apart. And what you get is, so I've got the sun, and the moon is moving in the way, and the first thing you're going to do is lose a bit of the sun. Now, if you want to look at this phase, you need to have the fancy glasses. What did I do with my glasses? There we go. This is what's going to be handed out at the end. They don't look quite like these, but you need these glasses. Now, these glasses are available all over the place. The library's got some. They're on sale in the bookstore at Mizzou. They're on sale in Lowe's and Walmart and Target and Hy-Vee and Gerbs and everywhere. And so you can get them if you don't get enough today. These only let in 1/millionth of the light that hits them. What it means is that if we go outside and look at the sun through these things, the sky will look black because there's not enough light coming from the sky. It will just look completely black. and the sun will only look as bright as a full moon. But it's completely safe. Just to show you how thick it is, here's my laser pointer, and if I move this in the way, it completely blocks out the laser pointer, right? In fact, I'm not going to do it right now, but well, actually, maybe I will. There we go. So if I can actually get it to stay pointed, which is really hard when you can't see it, it actually only looks about as bright as like a car in the distance, because this is only letting in a tiny fraction of the light. I'm not doing any damage. I certainly wouldn't do that without these on my face. So you need these whether you're using your eyes or any sort of a camera. You're going to need something to protect your camera. And that's how these images are taken. So here you can see the moon is moving in the way. Now, if you were just out there and you didn't know that there was an eclipse and you were just wandering around, you'd actually get to about here, about an hour into the eclipse, and you wouldn't even have noticed anything. The sky looks pretty much normal. But you get to about here, you're about 75%, 80% through, so the sun is 3/4 covered up. And it starts to get darker, but it's subtle. It's a little bit like on a stormy day, and you know there's going to be a thunderstorm because the sky goes a funny color. It's a little bit like that, but now what happens is the sky goes from its regular blue to kind of a just after the sunset blue, you know, before it actually gets dark, but the sun's already gone down. It goes to that color. And so you notice that it looks weird. And from about here until it actually gets to fully eclipsed, it'll get a tiny bit darker, but it's very subtle. It's still, even when you get to here, even with a tiny fraction of the sun showing, it still looks like early twilight. It's not dark. And then it goes from early twilight to full moon dark. And it's going to be full moon dark, and here in Colombia, around 2.5 minutes. At that point, the fuzzy white stuff pops up. I'll come back to that. But remember, everything is moving. So you get about 2.5 minutes in darkness. So it's about an hour to here, about half an hour to here, 2.5 minutes, and then the sun starts to show again, and you've got another 90 minutes till it's completely done. Now I'm going to focus in on what happens during the darkness. During the darkness, you get to see this. This is the corona, the fuzzy white stuff. It's actually the atmosphere of the sun. It's always there. It's not something that's made by the eclipse, but this is only as bright as the full moon. This is why it goes dark. What's showing now is only as bright as the full moon, so the sky is as dark as a full moon sky, okay? And the problem is that the sun is 1,000,000 times brighter. It's so bright that you just can't see this next to the sun. The sun is just so bright that it washes out everything else. And so this is the only time we can see the corona. Now this is actually a plasma. That's a fancy word for a really hot gas. It's about 2 million Fahrenheit. It's really hot. And it's so hot that the gas gets electrified. The atoms actually lose electrons, and this is electrically charged. And what happens is it follows what the magnetic field does. So if you've ever done the thing where you're playing with a magnet and you can make it move like iron filings or any sort of metal around, well, what's happening here is the sun's magnetic field is moving this gas around. And so what you can see is this is going to wiggle just a little bit. The red stuff you see here, this is real, and you can't see it naked eye. But remember, this is only as bright as the full moon, so you can point binoculars at this. You cannot do that during any part of the partial phase. But once it's totally eclipsed, you don't need these, you don't need anything, and it's safe to use telescopes and binoculars without any extra protection. So you can look at this. Now this is actually, if you've ever seen pictures of the sun, and they have these big loops of gas coming off the surface and flares and things like that, well, that's what you're seeing. We block the surface, but they come far enough off the surface that we see them over the edge of the moon. So that's what this red stuff is, okay? And it really is that color. And then we've got this corona. But this doesn't do it justice because, you know, our eyes are much better at detecting different levels of light than any camera. If I was to get my camera out now and take photos of people in the audience, there would be people whose faces would be hard to see in the picture because my camera wouldn't pick out those faces because it's not that good at different levels of dark and light. And that's true of all cameras. So this is really only picking up the brightest part of the corona. What it really looks like is something like this. Except that that's going to be black. The person who made this put a moon on there in case they forgot what was, you know, blocking things out. But here, this is basically what you really get. This is a real image of a corona, but the way that this is done is you basically take it for a picture for a short time to get the brightest stuff, and then you block that out and you take an image a bit further out for a bit longer, and then you block that out and you just stick them all together.
Can you see the corona with the naked eye?
Yes, you absolutely can see this. You won't see all the detail that you see here, because it's going to be a lot smaller than that, but you will absolutely see this. But there are other things you're going to get to see as well. Remember, it's going dark like a full moon night. And on a full moon night, you can see other things in the sky, like stars. And so what we're going to get to see are some stars. So this is the view from Columbia. If you're looking south, the sun is going to be almost directly to the south, and you're going to see all of these stars. Now, normally we don't get to see Leo in August. It's behind the sun. If you want to see Leo, you look at it in February, because that's when it's out at night. But there it's going to be. So you'll get to see all of these. We've got constellations that most people can recognize are up here in Ursa Major. That's the Big Dipper right there. And down here near the horizon, this is Orion. Most people can recognize it because those 3 stars on the belt are really obvious. Now, right here, this star that's right next to the sun, that star is the brightest star in Leo. It is called Regulus. For the Harry Potter fans in the audience, and I know there's a few, that is the Regulus that Regulus Black is named for. But not only that, so Regulus is going to be right there by the sun. Down here, near the horizon in the southwest, is Sirius, his brother. And if we look at Orion here, so Betelgeuse is this shoulder here. This shoulder over here is Bellatrix. So as well as just looking at stars in general, you're going to have to go looking for the Black family tree. As well as that, we've also got planets. So the brightest thing in the sky, apart from the corona, is Venus, and then Jupiter. And then a little fainter but visible will be Mars and Mercury. So there's a lot that's going to be up there for you to take in during the 2.5 minutes. But I'm not done yet, because I don't know if you can see this, but as you get down to the ground, the sky gets lighter. Now, if you've ever noticed, especially if you're in a car traveling west, in front of you, the sun has just set, and it's still kind of bluish, but you've got those after sunset colors on the horizon. But behind you, it's already black, right? Well, now you're going to get those after sunset colors, but instead of being just there in front of you to the west, they're going to go all the way around, all 360 degrees. And it will get darker as you go towards where the sun is. This isn't like anything you've ever seen. But at the same time, there are other things that aren't just visual. It's going to get colder. We just moved a really big rock between us and the sun. It's not letting any light in, and it's going to get colder. It's going to get colder by about 10 degrees. So, sounds pretty good to me in the middle of August. And because it gets colder, you get winds generated. So we think about this, that you've got this spot on the ground that's 70 miles wide that's got colder. But over here, away from the spot, it hasn't got colder because it's not blocked out, right? And so you have high air pressure here where the temperature's high, and low air pressure here where the temperature's low. And so it makes wind flow from outside to inside. So you get this wind coming in. So you're going to feel on your skin both the temperature drop and the wind. Now there's some other stuff that are going to happen as well. And actually it starts happening before totality. So when we get to the total eclipse, when you can actually see stars and you can look at it without the glasses, that is totality. But in those 20 minutes or so before, when we've got to kind of dusky colors, the sky is in those early twilight colors, the animals will start reacting. We know that birds do this. If you go out on any evening after the sun has set, you'll see birds doing this thing where they're swarming. They're swarming around, they're flocking together, and they make lots of noise. But by the time it's dark, they've all landed and gone quiet. What happens during the eclipse is that they notice that the sky has got darker. They start doing that before it gets dark. But then it gets dark and they all land and go quiet. So you really notice that they seem like they're going crazy because you don't expect them to be doing that in the middle of the day. And then they all go quiet, and so you really notice that change in volume. There will also undoubtedly be cursing. Now, let me just put this into perspective. This is such an impressive event that people just can't help themselves. Okay? So I want you to think about, and something that you've seen that you knew you wanted to see, but when you finally saw it in person, you're like, oh, whether it's the Grand Canyon or the Tetons or something like that. Well, now I want you to think of the Tetons sat in the middle of the Grand Canyon, but one of them's a volcano and it's in space. That's how impressive this is, okay? And so people just can't help themselves, so the cursing happens. So there's a lot to pay attention to. Other animals also react. Now, we won't see it here in Missouri, but if you're on the coast, there's some great videos from previous eclipses where dolphins and whales come up to the surface. I don't know what cursing sounds like in whale. Now I've got Dory in my head, sorry. So, there's all sorts of things. We think that cows will go back to the barn. Usually cattle will go back to wherever they spend the night. But we're going to have webcams on all sorts of beasties because, MU has lots of farms. And actually, we're interested in following some other animals. So the eclipse also goes over Wyoming, and Wyoming has bison herds. So we're hopefully going to find out what they do during an eclipse. Now, I want to back up just a little bit, and I want to talk about what happens just as we're getting to the eclipse. So this is when the birds are going crazy, and it hasn't quite got dark yet. And this is a time sequence. Here we can still see the sun. We see a bit less, and a bit less, and a bit less, but we're still seeing it. And here, you really don't notice, but here you can see kind of bumps and wiggles. That is the surface of the moon. The moon is not a perfectly smooth orb. It is cratered, and it has valleys and mountains and volcanoes. And so you've got mountains and valleys. And so what happens as the moon is moving into place and you're seeing just less and less of the sun, the last bit of the sun that you see before it's completely blocked out will be the deepest valley on the side that the moon is moving into place. So if you think of my face as the sun, my hair is the corona, which I'm kind of working on, but it keeps flopping and all being misty. And there's this valley, and you can still see my forehead, right? And there's only a little bit of my face showing, but that's where the light's coming from. And it's less and less and less, and then it's gone. That's the last thing you get to see before it is totally eclipsed. And remember that because the sun is 1,000,000 times brighter than the full moon, which is about the same brightness as the corona, even when you only have 1,000th of the moon, of the sun still showing, it's 1,000 times brighter than a full moon. So even with 1,000th of the sun showing, the sky isn't dark yet. You have to block it out completely. But this doesn't do it justice, because what it really looks like is this. This is the diamond ring. So you're starting to see the corona here, where we blocked out the sun, but there's a valley here that's still letting in sunlight, and it's so bright, it's like, whoa! And this will dwindle, it will get smaller and fainter as the moon moves this way and blocks it out. And this is the last thing you see through the glasses. And then when the glasses, when you can't see it through the glasses, you take them off, and it will be totality. But this is going to keep moving, and there's going to be a valley on this side. And that's going to be the first place that lets light in. So you'll get a second diamond ring, but now the diamond will be on this side. So let me just recap what's going to happen. You're going to have an hour of partial phase that's not very exciting. Then you're going to have half an hour where the sky's a funny color and the birds are going crazy, and the moon is blocking enough out that you've got a thin crescent of the sun. Then you get the diamond ring. Then it's totality. And in totality, you want to look at the corona and the stars and the black family tree and the planets and the horizon, and are you cold yet, and is there a breeze, and what are the animals doing, and are the plants doing something too, and then it's all over. So in 2.5 minutes, you have to take in all of that stuff. Okay? Now, I want to back up for a minute and talk about why we don't always get a total eclipse. Because we get a lining up of the sun, moon, earth twice a year, but only a little under half of them give us total eclipses. And it has to do with the supermoon. How many of you have heard of the supermoon? Most of you have heard of this. Okay, it's basically just the biggest full moon of the year. The moon's orbit around the earth is not circular. So here's the earth, the moon is going around the earth, and the earth is not in the middle, it's off to one side. And so when it goes around, it's closer at this end and further at this end. Well, if I bring it closer to me, it looks bigger, and if I move it away, it looks smaller. So what's happening is that it's going to look bigger at this end. Now, the moon goes around here every month, right? It takes about a month to go around, so it goes through this point every time it goes around. But it's only going to be a full moon about once a year. And so that's the supermoon. The supermoon is when the moon goes through this part of the orbit closest in, and it's a full moon at the same time. Now, what's that got to do with eclipses? Well, if this is a full moon, and this is when it's closest in, the next new moon in 2 weeks is when it gets over here, and it's too small. And now it's not big enough to block out the sun. And so what we get looks more like this. Now this is pretty cool, right? The moon is there, it's between us and the sun, but it's not big enough to block the whole thing out. And there is so much light still coming from that donut of the sun. And we call it the annular eclipse because, you know, the Ponzi name for a donut is an annulus. So this is the annulus of the sun, but it's still fairly light. You don't get to see the corona. You don't get to see stars. So even though it's kind of cool to look at, it's nowhere near as cool as the total eclipse. Now, actually, there's a lot of people who are like, oh, I remember seeing an eclipse when I was a kid. There was an eclipse that came over Missouri in the 90s. 1994, there was an eclipse, and it was one of these. And so a lot of you will remember that one, and that's the one that people are like, no, I've seen one. I'm like, did it get dark? No, but I remember going outside. Okay, it was one of these. The last one of these we had in the US was actually only 5 years ago, but it wasn't over Missouri. In fact, we had one of these somewhere on the planet in February. Remember I said we're supposed to have a lining up every 6 months. We've got an eclipse happening in August. There should have been one 6 months before that, which was February. And it was one of these, and it was also in the southern hemisphere. So now I'm going to show you where we get eclipses. So this is showing you, this is all of the eclipses that have happened or will happen between 2001 and 2020. The red lines are the annular eclipses where you can still see the edge of the sun around the moon, and the blue ones are where you get total eclipses where it actually goes dark. Okay? And there's a couple of things I'm going to draw your attention to. So this is the last annular eclipse we had over the US. I drove my kids down to New Mexico so we could watch it. This is the one that happened earlier this year. You had to be either in South America or Southern Africa to see it. But what I want you to see here is most of the map is not covered in ribbons, right? Most of it you could just see straight off. That means they haven't seen an eclipse. In 20 years, most of the planet doesn't get to see an eclipse, okay? Either type. The other is that it's mostly over ocean, right? Most of the time you're going to have to go beyond ocean to see this. And that's a problem for science because, you know, telescopes, boats, not a great mix. But it's also a problem just if you want to go and see these, it becomes really expensive. There are places that are hard to get to. Most of the world is hard to get to. And so it makes it difficult to see these things. People do go and see them. I know people who've seen 10, I know one guy who's seen 36 of these. To be fair, he's a solar physicist, but still. So if we look at what has happened, there's one here. This is over Indonesia. This is the one that happened last year. It was March 2016. It's over Indonesia. Lots of people saw it. There are lots of people live in Indonesia. But if you're an American, it's a long way to go. It's the other side of the planet. It actually takes about 30 hours on airplanes to get to Indonesia. My husband actually studies volcanoes. And I don't know if you know this, but Indonesia is basically a bunch of volcanoes. And he was going there for a work trip. And I'm like, oh, we could all go. And then I was like, 30 hours on airplanes with my children. Yeah, let's not do that. So we didn't go. So, you know, that was last year. The one the year before is this one up here in the Arctic Ocean in March. Doesn't sound like fun to me. Now, there are some land masses. This is Svalbard and the Faroe Islands. So basically, there are a couple of places you could go. But again, it's places that are hard to get to, expensive to get to. And in the case of Svalbard, it has a few too many polar bears. There are some amusing videos of astronomers being chased by polar bears. So, you know, you've got places that you can go to see it, but a lot of the time they're going to be mostly over ocean. It's going to be hard to do things. It also makes it difficult for us to do science because we're not going to get more than one shot. Like if you're on the Faroe Islands, you're going to get one shot of this. Whereas now, the one that happens this year, it's still mostly over ocean. Look, mostly over the Atlantic and the Pacific, but it's over land for a really long time. Now you'll notice that there are others that are over land. There's this one here that goes over India and China. First of all, those are places that are expensive and difficult to get to, but also if you want to do science, you have to get permission to take all your instruments and things in, which is not always straightforward. There's also this one that goes over land for a long time. The Brazil bit's probably okay, but this bit of Africa has had a lot of issues with terrorism and coups and civil wars. That's Libya, that's Turkey, that's the Middle East, and that's Russia. So yeah, it's over land for a long time, but possibly not land you want to be standing on. And also, it doesn't help with being able to do something where you want to get coordinated observations of what's going on all the way along the path of totality. So the next one I'm going to show you is basically the same thing, but now it's only total eclipses, and it's 50 years. This is 2010 to 2060. And the point here is that in a 50-year period, most of the planet doesn't see anything. Most people never see a total eclipse in their lives, unless they seek one out. Most people will never see one. And now we have one that's coming right over Colombia, and it's going to be awesome. So I want to show you like a history of eclipses. And this is every single total eclipse that has happened on the continental US, mainland US, since the US has been a country. Okay? The last one is this one up here in 1979. Now, 1979, there's plenty of people in the room who weren't alive then. I would have been in second or third grade. You can probably tell from the accent, I didn't grow up here. But if I did, I have friends who lived up there, grew up there, and they didn't get to see it because people were scared. People thought that the eclipse was dangerous. And so I want to reassure you, the children and the grown-ups, that all that's happening is we've got the sun, the moon gets in the way. The moon is not closer to the sun, it's not closer to us. It's just blocking the light. That's all it's doing. It's not focusing the light, it's not doing anything dangerous. Eclipse day is no more dangerous than any other day. Except that on a normal day you don't try to stare at the sun. And so, you know, basically as long as you have the glasses and you understand what to do to keep yourself safe, then there is nothing wrong with being out there the entire time. Now, it's August. If, like me, you're of Scottish descent and therefore pale blue, you know, August in the middle of the day sounds pretty scary. So, you know, what you would normally do in the middle of a hot August day, stay hydrated, have sunscreen, and, you know, and protect your eyes. And it will be fine, okay? So let's look at Missouri. Here's Missouri. The last time there was an eclipse over Missouri, a total eclipse, is this one here, 1869. And I have people who's like, no, I remember seeing one when I was a kid. And I'm like, you must be really old. The one before that is here, 1834, but that's basically over Joplin. This one's only really up in the northeast corner. There's this one in 1806, went over Kansas City, and then into the northern part. There hasn't been one in this part of the state since 1442. So it's a really big deal. You're going to get to see this. Okay, so one of my jobs, so I work for the University of Missouri, but with respect to the eclipse, I am one of two co-chairs of the National Eclipse Task Force. I'm not just planning for Missouri, I'm planning for the entire nation, okay? And so one of my jobs is, this is the Path of Totality, which is my heavy metal band name, but this is where you need to stand to see the total eclipse, okay? And I want as many people as possible to come and see it. Now, we don't want the whole population to come because it would be a little too snug, but also not everybody's going to be able to, right? But if I don't know if you can see this, but as you look up the side here or down the side here, up here, there's a tiny sliver of the sunshine, and then a bit more, and then a bit more, and then a bit more. The entire country gets to see a partial eclipse. So only this band that's 70 miles wide sees the total eclipse where it goes dark, but the entire nation sees a partial eclipse. In Chicago, they get a 90% eclipse. Up in northern Maine, they get a 50% eclipse, and that's as far as you can get from the path of totality and still be on mainland US. Even Alaska and Hawaii get a 20% eclipse. So my job is to make sure everybody looks at the sun that day and does it safely. Turns out there's a whole lot more involved in making that happen than you'd think, but we'll get there. Okay, so I want to bring a couple of things together. Here we've got the little black dot going across the country, and hopefully that then connects to, here is the path of totality. So the dot goes across, so somewhere on this path at some time you will get to see darkness. But as this goes around again, I want you to notice the bigger shadow. This is the partial shadow. So the whole of the US, the whole of Canada, the whole of Central America, Greenland, the Caribbean, North and South America, all see partial eclipse. In fact, even Western Europe and West Africa see a little bit of eclipse. England gets like 4%. It's really not worth it, but at 20%, it's worth it. So there's going to be like a huge number of people watch this. This will be the most watched celestial event ever, just simply because of where people are and how many people are going to know to look. Now, again, it takes time for this to go across, so what this one is showing is that you're going to see different things at different times. So the first place that actually gets the eclipse is up in Oregon. When it goes total in Oregon, we're only going to have less than half of the sun blocked out, but we're going to be able to see images from NASA of what it looks like in Oregon. And then it's going to go into Idaho, and we'll be able to see it go full in Idaho, but we've still got, you know, lots to go yet. So this is kind of showing, so that's Wyoming up here. I'll let it go around again. So it goes full in Wyoming, and then Nebraska, then here, and Tennessee, and South Carolina. And so you'll be able to watch it coming as it's being set through mostly NASA TV, but there'll be other places to look too. The other thing I want you to see is, look at Chicago. It's not as cool as getting darkness, but you get to see that. It's like the sun is 90% eclipsed for about an hour because it's basically the same distance from the shadow the whole time. Now there's one more thing that I want to mention that relates to where we are on the path, and that is that people want to be as close to the middle of the path of totality as possible. And the reason why is that the shadow it's not quite circular, but it's close enough. So if you're at point 2, right on the middle of that path that it's moving along, you'll be under that shadow for much longer than if you're up near the edge. So you don't want to be on the edge. If you're on the edge, you only get a few seconds. But if you're in the middle, you get the full 2.5 minutes, depending on exactly where you are. Now, where we are in Missouri, the center line goes through Columbia Regional Airport. So we're really close. It's actually slightly closer to Ashland than it is to us. Okay, we'll come back to where it goes in Missouri in a little while. One of my jobs is to figure out how many people are going to come, because it's going to be messy, okay? We need to be ready for this. And so we worked out that, and this is using census data, there are 12 million people that they don't need to go anywhere. They're going to get to see it. Now that includes people that are on the edge, and they might want to move because they don't get much time. But we've got, from census data, and extrapolating a little bit, we can tell you where other people are. So there are about 50 million people within 100 miles, 88 within 200 miles, 130 within 300 miles. This is going to keep going, okay? And the upshot is, this bit up here of northern Maine is 1,000 miles from the coast. And so this bit up here is the furthest you can get at about 1,000 miles, okay? Now, 1,000 miles is a long day's drive. It's a really long day's drive, but I've done it more than once with my children in the car, and we all survived. So everybody in the country could drive within a day. Now, I'm going to tell you a story about the last time there was a solar eclipse on US soil. It was in Hawaii, and that doesn't really help me because, you know, Hawaii, it's hard to get to, it's expensive to get to, and it's expensive when you get there. So it's not really an accessible spot. But they all have paths, right? So Hawaii's somewhere down there, the path comes up, and it hits Mexico. So in 1991, there's this eclipse in Mexico, and so many people were flooding into Mexico that the bit of border right here near San Diego closed. If you didn't have a reservation for a hotel, you could not get into Mexico. Let me say that again. Mexico stopped Americans going into Mexico. So I want to, so for the smaller people in the audience, you won't remember 1991. I know a lot of the bigger people won't remember either. So I'm going to try and remind you. 1991, I was a junior in college. I didn't have email. I got my first email address in 1993 when I started graduate school. Okay? Now, in 1991, I didn't even know email was a thing. Nobody used email. Nobody used the internet. Social media hasn't even been dreamt of yet. And yet, there were enough people coming through here that it was a problem. Now consider how many people communicate electronically and what social media does, and we have this path that goes all the way across the country and no borders to close to stop people. Scared yet? There's going to be a lot of people. We only need 4% of the population to travel to the path, and that doubles our population. And remember that there are 4 times as many people within 100 miles. There are 7 times as many people within 200 miles. That's people who think that they can drive down that day. They won't. And that's where we're at this point. Now, this map is a little different. This one is, you know, not everybody's going to drive to the closest point. They might have family somewhere that they want to stay with, but there's also other considerations like how cloudy is it going to be? I also love this map because it lets me explain the difference between accuracy and precision. You didn't know there was a difference between being accurate and being precise, did you? Okay, so let me explain a little bit. This map was made by taking cloud cover, and it's basically an average. And there's nothing wrong with this map. It is perfectly accurate. The data is fine. This is not very precise. So the way this was made, it's basically the local cloud cover at 1:30 p.m. for every day in August for 15 years, 2002 to 2016. Then you take an average, and then you've got an idea of what is it normally like in August from a cloud cover point of view. The problem is that it isn't going to be 1:30 p.m. everywhere on the path during the eclipse. And there are some other little things that need tweaking too. So let's start over here. Oh, and just to kind of get you to see what the colors mean. If it's blue, there is zero cloud and you can see the sky perfectly. If it is red, you cannot see the sky. For those of you that are not astronomers, clouds are not in the sky. They're between you and the sky. They get in the way. You can't see the sky when there are clouds. So, if it's red, it's completely thick cloud, and if it's blue, it's completely clear. Okay? So, if we look at this bit here, where the first bit of the eclipse comes, and this is Oregon, and it hits the coast here, that's way too optimistic. And this is where we get into the precision versus accuracy. The problem is that it's not going to be 1:30 p.m. when it hits the Oregon coast. It's going to be 10:15 in the morning. 10:15 in the morning on the west coast tends to be kind of cloudy, and so it's not going to be anywhere near this good. Okay. Now it's actually even worse than that because it's daylight savings time. So from the sun's perspective, it's actually 9:15. I don't know how many people really think about it, but you know, in the summer, the sun is at its highest point not at noon, which is when it should be, but at 1 o'clock because we added an hour onto our clocks. So at 10:15 in the morning, the sun thinks it's 9:15. So it's even worse from a cloudy point of view. Now, the eclipse comes over the Cascades and into eastern Oregon and Idaho. And at that point, this is good. Even though it's not 1:30 in the afternoon, that is high desert. It really is going to be that good. It's also going to be dry, which means that you will feel that temperature change more. So if what you want is to have the best chance of not having cloud and have the best experience of all of your senses, Oregon is the place to go. Unless you want to eat or sleep or poop, because there's nothing in Eastern Oregon. Let me just kind of put this into perspective. Like, I love national parks, and if you've ever been to like the bigger national parks, especially Yellowstone, you go to Old Faithful, which is just one of many stops in Yellowstone, and you've got like a city-sized parking lot. There is a park right here called John Day Fossil Beds. It has one visitor center that has 8 parking spots. And that tells you what you need to know about the facilities that they have. There's some other things that kind of bother me about this bit of the path, and into Wyoming too. So here in Missouri, we only have our federal land, our land that is looked after by the U.S. government is National Forest Service, and that's it. But when you get up into this part of the country, you have national parks, national forests, and Bureau of Land Management. And the problem is that not only is this bit already completely full, Jackson in Wyoming hasn't had a hotel room available for 2 years. It's completely full. There are no campsites, there's nothing. But the Bureau of Land Management land you can camp on. You can go up there and you can set up a tent and you don't need permission, and as long as you are 10 feet off the road, it's fine. But we're not talking about, a nice campsite that has a bathroom, not even a pit toilet. You need to go, you're digging a hole, okay? And you have to bring your own water too. But not only that, this is bear country. What do you think happens if you don't bury the poop deep enough in bear country? Not only that, it's also wildfire country. And you're going to have a lot of people who don't know about these things, and then they drive off the road onto scrub with a hot exhaust, and it catches on fire. So one of my jobs during the run-up to this eclipse has been getting the people up here ready for this, and thinking about making sure we don't have people eaten by bears or setting fires in place. Now, like I say, it's all full up here, and partly because it's, it's going to be pretty and it's going to have great skies, but also because they just don't have that many amenities, right? They don't have many hotels or many restaurants because there's just not that many people. You get into Nebraska and it's getting better, but there's nothing in Nebraska. Actually, so the interstate is down here, so it's not so bad here, but up here it's nearly all gravel roads. You get into Missouri, but oh, that doesn't look so good, right? It's looking cloudy. But this is where we get back to precision versus accuracy. This is perfectly accurate. What it doesn't do is tell you what sort of cloud you've got. So we actually look at what clouds we get in Missouri in August. So for the whole of August, on average, we get 10 days with no clouds. That's what I want. We have 10 days with cirrus. That's that nice wispy clouds where you can still see most of the sky. You might not see Venus, or it might block out Sirius or something, but mostly you're going to get to see things, okay? And then we have 10 days that suck and you can't see the sky. But that means that instead of being this kind of color here, where we're more than half cloud covered, we should be somewhere around here. So we basically have a 2/3 chance of having a good view, okay? But we also have no hills to block the view. The sun is going to be really high. It's going to be almost as high as it gets. And we have big roads. So if there is patchy cloud, people can actually drive on those. If you're up in this bit of the country, it's all little windy roads that don't have, you know, if you get stuck behind a tractor trailer, you're in trouble. And so really, let me just mention one more thing before we go on to that. So we have some advantages. As you get down here, you can see the cloud cover's getting worse. This looks pretty bad. It's hurricane season. So South Carolina, it's going to have lots of people because there's so much more, there are so many more people live over here and it's easy to get to. They're going to get lots of people anyway. But the chances of disappointment is high because they're just likely to have cloud. So let's look at Missouri. So this is where it goes across Missouri. So you can see it starts up here, right where Iowa and Nebraska meet, and the center line is coming down here just south of St. Joseph, which is where I'll be on Wednesday. And then it goes down through basically Marshall and Boonville, and then south of Columbia, and then on down here, there's St. Clair, DeSoto, St. Genevieve, and out into Illinois, okay? It takes about 15 minutes to cross the state. That's how long it takes for the whole thing to go across, okay? Now, you can really see here that we've got a lot of roads, so if you're in, you know, the Kansas City area, you can choose between a whole bunch of different places. Even here, if it looks like we're going to be cloudy, you've got both US 63 and I-70. I-70 is in the path for a really long time. If you're in the St. Louis area, you've got I-70, but also I-64, I-44, and I-55. So we have this advantage of infrastructure that is lacking further west. There's also going to be events at pretty much every state park anywhere in the state, but certainly on the path. There are, in fact, this includes the historic sites as well as the state parks, but half of the state parks are on the path of totality, and they all have plans. So now I'm zooming in, and you can see, so here's Columbia, this is the center line, that's Ashland, and that's Jefferson City. At the top here, Moberly just gets a few seconds, and then if we go down here, Eldon is just off the path, and down here, that's Rolla down here. So, you know, that gives you an idea of the extent of where you actually get to see darkness. And the closer to the middle you get, the more time you get. Okay, I'm going to zoom in a bit further, because I can. And so, here we are, and here's Ashland, and there's that center line. Zoom in a bit more. Okay, so that's the physics department, because what else would I mark on the universe? That's the stadium. My house is right about there. And we are, let's see, that one must be Providence, so we must be right about somewhere around there, right? So we're going to, right here, it's 2 minutes and 35 seconds. As you go in this direction, you get a little bit more time. So down in the south of the city, you're going to get a few seconds more. And if you go north, you get a few seconds less. It is not worth driving through what the clouds are going to be like for an extra few seconds. Okay? So this is what's going to happen. And it's going to be nutty. Now, part of my job has been, we got money from the National Science Foundation. And something that people don't realize, so NASA is strongly involved in what we're doing, but NASA doesn't do ground-based observations. Their job is to do astronomy from space. They have some other jobs too, but when we're talking about doing astronomy, their job is doing astronomy from space. Sometimes it's airplanes and balloons, And they do have some hot air balloons that are going to be set off so that we can get some observations of the eclipse from high altitude. But it's the National Science Foundation that funds telescopes on the ground. And so they're the people that funded us to do this because their job is ground-based astronomy. Okay. They do other things too, but that's the most important thing that the NSF does, obviously. And so they gave us money, and one of the things that we've done is to build this website. And this website is meant to be a hub for everything you could possibly need to know. It has teacher resources, it has safety guides, it has an event map that you can both look at to find things and register events at. It has all sorts of things. Our safety guide has been endorsed not only by NASA and the NSF, but also by the American Academy of Ophthalmologists and the American Academy of Optometrists, because we want you to believe us. But this is where you can go to find all sorts of stuff, okay? And we're still working. Right now, there's a weird thing going around about the specific safety advice that somebody's trying to scare you into not looking at the sun. It'll be fine as long as you have the glasses on. So we're trying to make sure we've got updated information on that. I'm going to finish up by showing you a movie of the whole path. And you can see here, this is the shadow that you can see right now. There we go. Oh, no, no. Okay, so it's moving, but you can't tell because it's over the ocean and there are no landmarks for you to be able to see. But in a second, we're going to see the coast of Oregon come. Oh, there it is. And it's going to hit the coast of Oregon at local time. It is 10:16 a.m. There it goes. Over Salem, Oregon, and then over the Cascades and into, look, there's nothing in Eastern Oregon. There's nothing there. And then it goes across into Idaho. And again, Boise is off the path. They will not see it. Everybody thinks they can stay there and drive up. They're going to get stuck. It does go over Idaho Falls, though, so that's quite big. Here's the Tetons, and there's Jackson. It goes right over the Tetons. The university has land in Lander. Casper is going to be really busy because it's where I-25 intersects the path. If I didn't live on the path, this is where I would go, Alliance, Nebraska. If you've never been there, they have Carhenge. It is Stonehenge built out of Cadillacs. Here's I-80, so you can see, start to have more population. But just look what happens as the shadow gets into Missouri. You really see how many more cities we have, how many more big roads we have. And that's an advantage. Plus we have big airports at either end of the state, which makes us popular. It should just keep going. So there are going to be thousands of people coming to town. I would say that if we don't double the population, that would be a surprise. But realistically, we've got 4 weeks, but we won't have good weather predictions, even anywhere near close to good weather predictions, until a week out. And so we really won't know how bad it's going to be, or good. So my advice to all of you is fill up your cars on the Friday before, do your supermarket shopping on the Friday before, and then find ways to minimize anything that you have to do that weekend. There'll be lots of fun things to do, but if you can just chill with your family and enjoy the show, that'll be best. And I'm done.